Okay, this is going to be a solution to the knockout round of 128 in the Microsoft Excel World Championship. This is Hopscotch by Kobe, and this was a very hard case, the lowest scoring case. I think layout is key to this one, and the first two questions lead you down an incorrect layout that's linear, as you can see by these arrows. So it's kind of going from 1 to 10 and then back again, stepping on each square once. Whereas in reality, these doubles are actually one step with both feet. So you want to lay it out so each row here is a step rather than linearly. So that's what I'm going to do. So first of all, let's just do a setup that solves for level 7 and all the other levels. And then you're going to see this is going to be quite quick with my approach and layout here. I'll try and explain as much as I can though. So first of all, I want to get the score for each grid, and that is based on color. And I have a robot command that converts colors into their numbers. So let's just apply that there. And let's also apply it here and to this one. I'm going to shorten this grid as well because that's going to be too big. So let's copy that, paste it and get the colors out. And let's just reduce the size of this. And now you'll notice that because these are kind of merged across center, these numbers, I get 2 of the color code out, whereas I only want 1. So I'm going to say if this, so if that, then XLOOKUP this in here and give me here. And what you'll see is that's only going to give me the numbers where it's relevant, otherwise it's going to give me a false. So if it's not there, I'm actually going to say NA, and I'm going to call all of that with a 3. So call, comma 3. And this is our points for each square. And then if I say call this, comma 3, that's our squares. So this is our points. So let's just grab our points table, and then we're going to do the same on this one. So if this, then XLOOKUP this in here, give me there, otherwise NA, and then we call 3. Call 3, and let's grab the squares, call this 3, and we have a hard-coded points table. Now let's label my numbers here, we'll call it simp for simple, and then we'll label this one up to H because that will capture everything. We'll label this WC for World Cup. So let's get into the easy method. So I'm going to say if simp, give me simp, otherwise give me blank. And what that's going to do is going to spill out the path here. So let's just center everything up so it's nice and neat. And what I want to do is basically stack this on top of each other, but with the reversed path as well. So the reversed path is going to be this backwards, but I'm going to take off the top and bottom row. So I get all the middle twice, but the ends only appear once. But I'm going to go one step further and actually set this up for the last question as well, to remove stones. So if I just go to example 5 for a second, actually let's go to example 7 because it's the longest one. So these are all the stones we need to remove. So I need a way to turn these off. So I'm going to say if isError xmatch the grid on where all the stones are, then give me what we had before. That means they're on, so they don't appear in this off list, otherwise give me blank. So that won't do anything here because no stones are below the number 11. But if I go to example 5, I think has stones, now you'll see 4, 6 and 10 are turned off. So 4, 6 is this one, it's actually here in this grid, and 10 are turned off. So now in this example, I want this to be step 1, 2, 3, 4, and this to be step 5. So I want a way to filter out all the blank rows here. So I'm going to say by row, this, lambda A, count of A is greater than 0. So that's going to tell me if the row is kind of active or not. And at that point, what I can do is I can say let A be filter this, where this, and that's all I need to do for a second. If I just show you A, that's going to spill out only the relevant path. Let's actually make that smaller as well and center it all up so it's nice and neat. What I actually want to do is I want to vstack A with the reverse of A, and I'll just show you what that looks like. So my reverse lambda, basically if I just take a list, it will just reverse that list. So all I'm doing is I'm reversing this order. However, I want to take off the top and bottom rows of it. So in reality, I want to say drop column 1, and I want to drop the final column as well. So now we have our path, and if we go back to example 1, you'll see that that's a clean path from 1 to 10 and then back again. So really our route is just going to continuously repeat this. I have another lambda called vstacks, which just repeats an array multiple times. So I'll repeat it 20 times, and that should be enough to see us through the path. Now for example 1, all we want to do is determine what square we're on after this many steps. So let's just add a few columns here for some workings. So I'm actually going to have to manipulate this for questions 1 and 2, but for the rest of the case it will be easy because this is the actual, each row represents one step. So, but for question 1 we're going to have to 2-col it, which is a little bit annoying. So let's say equals 2-col this, and what you'll see is I'll get the blanks, so I don't want the blanks. So again I have to eliminate those manually. So let's say let A, if there's a quick way to omit blanks anyone knows, please let me know. So I want to filter A where A is not equal to blank, and then I just want to say index this on this number, and that is going to be our answer for all the questions. So let's data table that, and that's question 1 done. And then question 2 is asking how many points we have up to that point. And from now on, all we care about through the whole case is number of points. So the steps are kind of irrelevant. So because I only care about points, I'm going to say xlookup that in our step numbers and give me our points. If it's not there, give me a blank. So now our steps are converted into points. These are converted into points. And we need a cumulative running total. So we can just say equals scan 0 this sum, and this is our running total of points. So now we just need to move this over to here, and we go to question 21 onwards, and this will be our points now. Okay, level 3 is exactly the same, but we turn the stones off. So example 3, because we don't have a right or leg foot as well, I just need to move my stones over to here in my formula. So now you can see we've turned stuff off, and from question 41, this should be all of our points. Actually, we did miss some bonuses, so let's just do these. So question 2, which hop do you get exactly 1,000 score? So I did this manually before, but I noticed earlier that actually the answer is one of the questions as well. So it's this 169, so that would be the most efficient way to do it. But yeah, I mean, you could do it manually. And the opposite way around, we want to know what the score is after the 1,000th hop. So let's just turn all the stones back on, and we want to know what the 1,000th one is. So I don't think we have 1,000 here, we have 360. So let's extend our range by, I don't know, let's just go to 100 just to make sure we get it. And I'm going to say index this 1,000, and that should be our answer there. I think we're on question 4 now. So this is where the leg comes into it. So from this point on in the case, the answers are always going to be what leg do we finish on and how many points do we get. So we need to add the mechanic in for what leg we're on. So equals this, so that's going to be what we start on. For the next leg, I'm going to say if count of this is greater than 1. The reason I'm saying greater than 1 rather than equal to 2 is because in level 7 there can be 3 blocks here. So if that's true, it's going to be both feet. Otherwise, if the last cell said both, that means we need to swap leg. So how do we swap leg? We're going to say if the one before that both was right, it will become left, otherwise it will be right. And if all of those are false, it's just going to be whatever the last leg we were on was. So as I drag that down, you see we stay on the right leg until we hit both, then we'll swap to left leg, then both, then right, and so on and so on. So all we need to do now, actually the last thing we need to do is un-2-col this, because now these are steps instead of stepping one by one. So that's where the question kind of, the layout that's inferred from question 1 and 2 would really mess you up here. So at this point, I just want to say equals by row this sum. So we get the sum of each row, and that's our points. So we just need to add in index this, and we want this, and a dash and that. Now I might actually just drop this down to be maybe 200 big. This is one thing I don't really like, is where I work in a non-dynamic array way with a dynamic array way. It doesn't work too well. I also don't like the look of these answers. It's probably because we've not changed the question numbers, and we have the data table issue. So I don't know why Excel does this, but the data tables just don't calculate. It's really annoying, but let's save the file, close it down, and as soon as I reopen it, you'll see that it all comes back and calculates correctly. It's a really annoying bug that I don't know how to get rid of. Now there's also a bonus for example 4. What is your score after the 1000th hop? So that's going to be index this 1000. And there's our answer for that one. Level 5. So this is 81. I mean, this is already going to work because of the setup I have now. So I'm already going to be turning stones off. I just need to move that across, and this should just be the answers. For level 6, we have, the only difference is we have a multiplier for each foot. So now that I have this built, this is kind of easy to add in. So it's going to be that times XLOOKUP. I actually need to make this the same size as my array, which is going to change, which is really annoying. So let's just do equals sum. Let's change it to a non-dynamic array way of that times XLOOKUP the foots in here. Give me here. So this is the problem with trying to work with a dynamic array and then a non-dynamic array. I'm also going to get rid of this just to make it slightly more efficient. And then this now is just going to be that equals that plus what we had above. So the non-dynamic version of things. And now we can make that, and we can make this our cumulative points. And we have a hash symbol in there still, which we shouldn't have. And we need to go from 101. So once you have the model set up in this way, with the steps spilling out one by one for all the things that are active, it's actually a reasonably easy case. But layout is everything. You're never going to spot this first time. So example 7, the differences here is we're now in the big grid. So instead of simp, we're going to say WC, 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 and we get this huge grid out. The reason not everything's coming up is because the points table needs to be on the other tab. So the points table is going to be here, and this is going to be here. So that's the points for everything in that level. Why is that so slow? I don't like that at all. I think we might have crashed. No, we haven't. We're good. So here's our new path. This is spilled down. This is all dynamic, so that's fine. That's updating all right. And then we need 1 4 1. And where's our stones coming on from? Again, I don't like this data table nonsense. Let's turn the data table off for a second and hope it sorts itself out. So I need a bigger, the reason this won't work is because I'm going to need a bigger drag down here. And then I'm going to change this to this. And I'm going to change this bit to this. And then the last thing I need to do is where we land on 3, we have 3 options instead of 2. So here's a good example. We have 3 options. We take the largest 2 of them. So this score is actually going to be if count, let's just do it from the top so it's a bit cleaner. So I'm going to say if count of that equals 3, then do sum of large this, comma sequence 2. So that sums the largest two values. Otherwise do that times the XLOOKUP. So this is our new points. You'll see our score now matches the example. And let's pray a data table works. Otherwise I will turn this into a lambda with lambda robot, which seems to be a good way around these data table issues at the minute. I'm kind of forced into a single cell approach because of this. So 1, 4, 1, let's just try them manually, see if it gets them out from, oh, example 7's 1, 2, 1, that might be my problem. There's no question numbers for that. That's completely stupid. Painfully, let's just give it a second. There we go. I'm not even sure if that's right, if it's had time to calculate, but it is, okay. Anyway, how many games in level 4 and 5 were the final foot the same as the starting foot? So 4 and 5, that's just going to be equals text before this equals this, and I want to convert that to numbers. So that's that, and then for question 5 I want it to be over here. So let's do, these pictures are annoying when you need to work there, although they are actually very handy in this case. So that's 22, and then for level 7, what's the highest number of left foot hops within a game? So I'm going to say equals take this number of rows, and I want to say sum of minus minus that equals left. So the answer will just be the maximum of these, which is 819. So 819, and that is hopscotch done. So yeah, I do think this is a very clean way to do it. I like to do things visually. I'm not very good at single cell, so I have to kind of spill it out like this to see all the steps for debugging and whatnot. But that is my hopscotch solution. I hope you liked it. See you next time.